good morning, everybody, or good evening, wherever you are in the world. Welcome to another edition of VFX Live Houdini special. Today, I think we're going to finish off what we've been working on for the last couple of weeks, and that's going to be the tornado example. So, if you haven't seen that, go and have a look at the other two versions of that I've done, so you can see where we got to. Hey, Audrey. Good morning. Good evening. I mean, I think it's good evening to you. How you going? Thanks for joining me. So yeah, let's just jump in, and I'm just doing a flip book and still just finishing off. It's got a little bit longer to go, just to see where we left off last time. Yeah, I'm good. Thank you. Had a good weekend. Good morning. Yeah, I've got my coffee. I'm ready to go. Ready to do some Houdini. Have you touched Houdini yet, Audrey? One of these days, I'm sure I'm going to get you hooked and you'll be like, this is the life for me. So, yeah, I'm just going to see what we got to. This is almost finished, up to frame 400. I like a lot of things that are going on here, but I want to spend a little bit of time, first up, just trying to make this feel a bit more interesting. That's right, watch out, everybody. Hey, Robert, how's it going? Joining me before dailies. So, yeah, I want to make this, this house feel a bit more interesting. It's kind of, the destruction is kind of cool, but it's not amazing. It's just kind of, it happens, pieces peel off, and it's not that great. And these pieces up here as well get a little bit kind of stuck in the air, which is a bit weird. So I definitely want to resolve that. What I think would be cool is if we could get some pieces sort of just want to not work today. Yeah, I know the pain. Mondays, hey. Hey, Hardik, good morning. Thanks for joining me. So, yeah, I think it's getting a few pieces peeling off earlier, and one thing I'd love to try and get, and I don't know if I'll do this through rigid bodies or maybe have a crack at doing it in vellum. Yeah, I'm great, Hardik. Thank you for asking. How are you? One thing that I think would be cool is maybe with vellum or maybe with RBDs we can get it, is to get some of these sort of sheet metal roofing components to flap around beforehand. So this is finished. This is finished, and we'll have a look at what we've got. So, if you're thinking about this in terms of an actual shot, let's say in a film, we probably wouldn't see this first kind of 200 frames or even the first 300 frames of the twister kind of forming, but that's what we've got in our simulation. It probably, we might cut into the shot here where we see this sort of thing. So it may only be vellum wires. Yeah, I look farm and mysterious. I'm sure you didn't mean to write farm, but thank you. I added a new light behind my guitar there. Is that why I look so mysterious? So I also shaved. Maybe that's adding dark. I see. It is dark in here, although it is sunny outside. Yeah, right. So yeah, let's just jump in and see, and then I got it. Thanks. So let's have a look at our .NET. It starts at frame 150. And so we've got this kind of behavior going on. You can see like these sheet metal bits, they just all sort of peel off, and they're very rigid. They're not flopping around. In reality, these things, when you see videos of sheds being destroyed, that's right. There's something different about you. I can't put my finger on it. I went to an industry drinks thing here in Melbourne and caught up with some people that I hadn't seen for a couple of years, and yeah, so I thought it's time to time to shave and, you know, make myself look presentable. I haven't left the house in, in basically a year. Or I haven't done anything like that, anyway. We have COVID to thank for that. So, yeah, that's right. So yeah, I think let's try it. And we don't really have any. We've got our constraints here, but everything's just kind of peeling off, you know, all in one big go. So that's something that I definitely want to try and improve on. And I think the first step would be maybe to improve our soft constraints that we have here. So yeah, Hardik, I'm just gonna keep kind of refining what I'm doing with this bullet sim, and then if that kind of doesn't give me the result that I want, I might go into Vellum and see what I can kind of get going with Vellum. Let's. I'm still really confused as to why this side is producing different constraints to this side, but anyway, I guess that's just the way it is. So let's see, what have we got? We've got our connect adjacent pieces. So let's just increase the radius slightly, and that should yield, you can see, going from 0.5 to 0.8. That should yield more connections. We could even go 0.1, that will yield even more. So then when we solve with more bullet soft constraints, we should get more things kind of hanging together. And it would be cool if these were actually hanging together. So let's try and see if we can get that happening. Let's just have a look here. Just want to make sure that these bits of roof are actually separate bits of geometry. They are. Let me just bring that across. Oh look, I have a camera in my scene. Yes, I do. I've got multiple cameras, I think. I've got 1, 2, and 3. So yeah, fancy. So I want to see some connections between here. What I'm going to do is right down here I've got this assemble, which is creating the name attribute for everything. But instead of doing that, what I'm going to do is up here, I'm going to create some names. And this will help me later on if I ever want to split things after the .NET. So here, I'm going to put an assemble, and I'm going to call this one roof. And then I'm just going to duplicate that, put this one here, this one can be roof beam, something like that. And then what else have we got? So you can see there's a lot going on in here. We've got our... there's a double up happening. That's probably why I have... So there's a little mistake. Here I've got my copy and this mirror, and I thought the mirror was only yielding one side, but because I've got keep original turned on, I don't actually need that, so I had to duplicate one side. That probably owes to my extra constraints. So there we go. Found something. So let's put an assemble on there, and we'll call these, I don't know, roof beams, something like that. Maybe we'll call this one like roof big beam. You can have multiple cameras in Lightwave. Yeah, that's good. I mean, it's a pretty common thing to have multiple cameras in any 3D package, because, you know, you want to look at things or render things from different views. So let's see what else we've got. We've got here, let's call these like ceiling beams. And it's good practice to do this when you're building a model. I mean, I kind of just rushed through doing that stuff. Oh, look, I've got another duplicate thing happening here, I think. So, yeah, I've got that templated. That may be why. Oh, maybe it looks like it's kind of stuck in my viewport. So annoying, Houdini viewports, the way they do that. Okay, there we go. So we've got one wall and another wall. So that one's not duplicating. So here, let's call this one... Let's call this one weatherboards. Weatherboards. Now you have to be careful because here I'm duplicating the geometry, and what will happen is I'll get duplicate names. So when I do this merge, the names of the weatherboards on this side will be exactly the same as the weatherboards on this side. So I do have to be really careful about that. I mean, probably the easiest thing that I could do here is do this rotation up here instead, just on the weatherboards by themselves, so that I merge like that. The other option would be to create like an offset in the name attribute, which I could do as well, but yeah, I'm just going to go for the nice, easy approach. So let's go like this as well. So I'll do all of this stuff kind of up the top rather than in this merge, because that will affect the names. So I'll get rid of that. Don't need that merge. I'll just go up here like that. So let's see, what have we got? We've got oh, cool, Hardik. Thank you. Yeah, I mean, look, feel free to suggest them anytime. I'll definitely take them on board. But yeah, if you want to wait till the end, that's fine. Somebody in the comments also suggested a tidal wave, which could be cool. Could be a cool thing to work on. So I'm going to call this wall cross beams. And I'm going to do this rotation up here, like that. Yeah, I think a wave could be really cool. I saw I saw a really cool example of a 3D wave recently. I can't remember who did it, but yeah, it really inspired me to do something like that. So yeah, we could definitely a tsunami filled with mecha anime girls. Well, that's not what I was thinking, but it sounds cool. I'm not sure that I could do that. Well, yeah, I'm sure I could, but that's a good idea, Audrey. Let's see, what am I writing? Wall upright. That's right. I can fill it with elephants. Like, you know, we all know I've got lots of elephant models, so let's see. Or I could fill it with Tommy's. You know, Tommy's always a good one to just chuck in there. Maybe make him like a soft body, have him flopping around. Okay, so I think I've got my names sorted. So I've got my wall cross beams. I've got my uprights. Oop, get my spelling right. You could, but should I? Yeah, that's right. I mean, there's a line. You know, there's a line. Maybe that would be crossing it. So I think all of these things are named, and you know, a good way to check would just be to run it through the simulation, but we should be able to just make sure. So the roof here. Now what we can do, because we have all these things as separate names, is we can actually make separate... Oh, look, this... Yeah, it's so weird. Oh, you know what? I think I'm doing it again. I'm duplicating with the mirror, with this keep original. So I'm going to... I could turn that off, or I could just get rid of that. And then... Hey, there we go. That looks better. So that may fix all my problems. So let's just check down here. There we go. So that looks better. Let's run that. Always a good idea to just check and make sure you're not kind of messing stuff up. So let's see what's going on with our bullet constraints, because they don't seem to be holding anything together. Or they're stretching a lot. So let's increase on the bullet soft constraint. Let's increase the stiffness. Let's go 10 back to default. There you go. So you can see the stiffness now is really kind of holding those things together, and they're not breaking. So you can see that like that. So I don't know if that's totally what I want, but let's just decrease this search radius now, because I did up that. So I'll go 0.8, maybe 0.5 was what I had, but maybe this will work better now that I actually have less kind of broken stuff going on in my setup. All those overlaps wouldn't have been helping. So you can see they're still constraining together. And let's see what happens when the tornado actually hits and these get ripped off. But I kind of like, even though it's not quite perfect yet, there we go. So the bullet constraints are really just holding everything together, which is kind of funny, but not really what I want. So, but you can see they're kind of moving and jostling about a little bit, which is kind of cool. I like, you know, I like that sort of just wobbling in place and not completely being ripped off. And then, you know, at some point they could be sort of torn off. Oh, there we go. So I just turned that one off. I meant to actually just disable the view. So with bullet soft constraints, they don't break by default like a glue would. So glue has an inbuilt ability to break, but you can see with this, it's just staying rigid. So it's not going to break apart in those soft constraints. So we need to kind of tell it to do that. The other thing that might be cool is actually constraining this to the ground so that the things like the poles, which should be kind of stuck to the ground, will actually stay in the ground and this thing can't actually move around. And that might help with the overall destruction. So what I might do there is from my uprights, wherever they are, I should label these things so they're easier to find. So I think right up here, here's my uprights. So from here, because I've already created this name at this point, I could actually create a connect adjacent pieces, but I don't have anything to connect it to down here. The other thing I could do is actually just deactivate these pieces. So if I was to create a, actually let's do it down here. You can see down here we've got this name. So we can actually, if we have a look at the geometry spreadsheet, we can actually affect things based on their name. And this is why it's really good to have unique names, because we can use them kind of like a group. So you can see here's the wall upright beams. So if I was to put a wrangle down here after the pack and say in the group @name equals upright, so I think it's wall underscore upright underscore beams. Let's just double check. Wall underscore upright underscore beams star. We'll grab all of them because there's different numbers. And then in here, if I just say I@active equals 0, you can see they all go 0, but let's just put another attribute wrangle before that, which doesn't use a group and sets all the active attributes to 1. So first of all, we're setting them all to 1. So you can see that they're all active 1. But then this one, you can see, here's our wall upright beams, setting it to 0. So it's using that name as a group and applying that line of code. How do you remember node names? Well, practice. Yeah, I think, you know, the memory side of Houdini, there's a lot to remember, and it's just practice. The more you do it, the more you kind of remember what you need to put down in the correct kind of, in the scenario that you need. That's right. I just installed Houdini directly into my brain. Yeah, there are still some nodes that I always forget the name of, and often it's because they're not named like what for the thing that they do. So that sometimes, you know, can be a hard thing when you can't really remember. You know what you want it to do, but you can't remember the name of the node. The ends SOP is something that I always forget the name of. But the more you do it, the more it sinks in. It's just practice, and you just have to keep practicing. And every kind of project that you do, every setup that you work on, you will remember like what you did last time, and you're like, oh, I know, you know, last time I did this thing, I used this node. that worked really well for me, so I'm going to try that again. So you can see here what's happening now that we've deactivated those uprights. There's some crazy stuff going on, and that's owing to the soft constraint kind of springing everything together. But you can see how these beams aren't moving at all, and everything else is kind of just jumping around and bouncing around like crazy. So that's kind of cool, but we need to fix it so it's not completely broken. So the reason these are just jumping around is because the bullet constraints don't break the soft constraints. They're just always together and holding stuff together. We should also, just because these ones in the center here look a bit weird, so we should also just double check that we have rest length on our connect adjacent pieces. So we've got it ticked on there. I don't think I'm not using that one, so that's the only place. The last thing to check is just the collision object as well. So if you've ever got weird behavior, it's a good idea just to check the collision object and make sure that you're not seeing anything kind of strange happening there. But those all look fine, and because we use boxes, that's kind of, you know, that's kind of why they're all good. These ones, I think we can probably change that collision padding. Let's revert it to defaults. So I think, yeah, let's go 001. Just try and get that as close as we can. We can even turn off shrink. That might help. Let's try it. It might make it worse. It's always, you know, a bit of a gamble playing with the collision padding, but let's see. Yeah, that's right, Hardik. I think it's just practice. The more you do it, the more you'll remember. Unfortunately, there's no kind of shortcut. I mean, you know, when I was learning Houdini, I would keep a Google document of things that I wanted to remember because it is so hard to remember everything. Little lines of code, little expressions, useful nodes, or even the settings on nodes I would write down. If they were particularly good, you know, let's say I was doing fire and I really wanted to remember how to do that again, I would just write down the settings on the pyro solver. And I would refer to that, you know, if I was ever doing something again and I wanted to kind of recreate it, I would refer to my notes. So that can be a handy way, just taking notes of certain things, writing down nodes, you know, and what they do. That can be kind of helpful as well. So we've still got crazy stuff moving around, but let's now break these bullet constraints when they satisfy some kind of constraint. So in this SOP solver here, we're doing some stuff breaking the glue constraints. So we're going to do a similar thing with the soft constraints here. So put a SOP solver down, come over to relationship geometry, and you can see our bullet constraints here. So if I hit play in here, you won't see anything updating in here because constraints don't actually move inside this SOP solver. But if you have a look at the geometry spreadsheet under primitives, you will see there's a bunch of attributes that will be updating. So let's have a look. We might need to jump out and let this solve. Let me just go back to my scene view. Let's just let this solve a little bit. Tips for beginners learning Houdini, do's and don'ts. Look, I think it's really important to learn the fundamental aspects of Houdini, how attributes work, and how you can use them to modify geometry. I think there's always a tendency to don't start. No, definitely do start. It's great, and it doesn't have to be, you know, as hard as people make out. It's definitely challenging software, but I think, you know, the important thing is to make sure that you understand the way that it works before you try to go into really complex things. So really understanding attributes, really understanding, you know, what's going on in this geometry spreadsheet. Because once you understand those things and that part of it clicks for you, then you can kind of figure a lot of stuff out, and it allows you to move forward a lot faster. Whereas if you don't understand that stuff and you ignore all that fundamental way that Houdini works, then it's going to take you a lot longer to really understand what's going on. And being able to modify things and just, you know, being able to create your own stuff instead of just following along tutorials, that understanding those basics is really, really important. And most people kind of will try and skip over it because they want to do an explosion or rigid bodies, you know, the stuff that I'm doing here. It's fun to do this stuff, but you'll get to a point where you can't kind of progress because you don't understand really the way that it's working. So that's my only advice is do some introduction stuff which teaches you about how attributes work. And if, you know, things like Vex are confusing, then just focus on VOPs and learn how VOPs work, and then you can start applying that knowledge to Vex as you start, you know, kind of developing that understanding. And yeah, there's always so many ways of working in Houdini that it doesn't have to be one way or the other. You don't have to be super technical. You can be more creative. You don't have to go crazy with the Vex. It is really handy, makes life easier for a lot of things, but when you're learning, and maybe you're not that way inclined, don't feel like, you know, if I don't learn this, I'm not going to master Houdini. So in here, now you can see these attributes updating. These are the soft constraint attributes. So you can see we've got force, distance, angle. So angle is basically, you know, how that soft constraint is bending, what angle it's at from its original position. The distance is how far it's stretched from its original position. And the force and the torque are the kind of forces that are acting on that constraint. I usually use angle or distance. Force can be a good one to try as well. But basically what we can do is break these constraints once they satisfy a condition like greater than an angle. So, no, you don't need programming language knowledge. You can develop a knowledge of Vex over time, but you definitely don't need programming knowledge. You know, it definitely helps to learn some Vex, but I don't, you know, I'm not a programmer. I don't have in-depth knowledge of other languages. I've tried to learn Python in the past and just kind of gave up. It's not really for me. But, you know, learning Vex and developing that over time is really a good kind of thing to do, because it does make certain things easier. So here, for instance, I'm going to create an if statement, and I'm going to say if the angle here, this angle attribute, is greater than a certain value. So I'm just going to like sort these, and this is going to error because I clicked off it. I'm going to sort these angles, and by clicking once or twice, you can kind of sort between minimum and maximum here. So when I click and I see the larger number here, that's the maximum value that we're at on this particular frame. And if I kind of scrub through, I can see that, you know, those aren't really going too much bigger than that. So I'm going to pick that as my starting point. So I'm going to say at angle greater than 0.04, I think that was. Very small number, but it's in radians, so it's not degrees. And if you just Google radians to degrees, you can get a converter. I can't remember what the ratio is, but that's okay. It doesn't matter. We can just use the numbers that we have. We don't have to know exactly what degree it is. So at angle greater than 0.04, and now I'm going to remove, and actually we're going to run this over primitives, so I'm going to remove prim. Because the constraints are primitives, they're polygons, so we're going to remove them. And you can see when you're typing Vex, it's handy to use these tooltips that pop up when you write an expression like this, because it tells you what you need. So geohandle is just the geometry. And usually when we're doing stuff like this, the geometry that we're running it on is the geometry that we've got plugged into the first input. So you can put 0 here, or geoself, but usually I will just put 0. So 0 just means the first input. If you put 1, that's the second input, 2 and 3. So we're just running over the first input. And then if you go back, you can see the second thing that it needs is primitive number. And the last one is a kind of Boolean, which means it's either a 0 or a 1, which is asking, are you going to delete the points that are connected to those primitives? Yes or no? So 0 would be no, 1 would be yes for that. So we're going to do 0 for the first input. We're going to run this over all primitives that satisfy this argument. So prim num, and then we're going to delete the points connected to them as well. So 1 for yes. Close that off. And then if we run this, go back to the start. Let's run this and see what happens. Just going to show this one, this view. And waiting. Hopefully something will happen. Here we go. So I'm just going to run that. I'm just going to run to my front door because I think there's a postman here. Just I'll be right back. But I'll let this run, and I'll be back in 2 seconds. Sorry about that. So, let me turn my camera back on, there we go. So, I don't know if we can see it. We might have our number value too high, because nothing seems to be breaking. So let's go and just decrease that number here. So I'm going to say, oh, actually, this is why. I forgot to change this. So here I've written remove prim, which is acting on primitives, but I've got it here running over points. Always with constraints, you want to run this over the primitives. So let's go back and try this again. Hopefully we'll see something break. And we'll see it here. If it does break, we'll start to see these things kind of, these white lines disappear. And you can see I've got a piece falling off. That's a good sign. It means that probably that constraint there has broken. So that angle has gone greater than 0.4 on that piece, and it's broken them off. And you can see it's rolling around like crazy, and that's because of the velocities of the tornado. So see how all these white lines are starting to disappear? And we're starting to get something a bit more interesting happening. And you can see those pieces, those sheets of roof are actually peeling off, which is kind of cool. So it's a little bit more kind of complex behavior that we're seeing now. So maybe that 0.04 is a little bit low, I think. We can go inside again and check our angles. So we've got 0.03s here. All the ones that are above that are going to have been removed. So let's go 0.02. Let's do half of that. So you could use Houdini software for animations. Yes, you could. Do you mean like character animations, Hardik? I'm just going to, on my rigid body solver as well, this sleeping time value, I'm just going to set it to 0. I've noticed recently when using Bullet that the sleep seems to kick in pretty soon, so I usually turn that to 0 so that it doesn't freeze any of the pieces accidentally. So I've noticed that it does kind of kick in very soon. So let's just see how this works. You can see those disappearing, you can see them breaking. And now we're seeing a different behavior, where we've got pieces kind of peeling off here, but all these pieces are kind of staying together. There we go. See that kind of hanging together a little more. And then as it goes up into the air as well, it it can separate and break further down as it's kind of flopping around. So it might be kind of interesting to see, you know, these little clusters hanging together, but then at a certain point they might sort of break apart more. Or we could do that in the slop solver as well based on some sort of time. You can see at frame 400, we only have our tornado cached out to 400. You can see what happens right after that. They just, all the velocities basically, you can see the poppered vectors erroring. The velocities are just ending and they all drop down to the ground. So that's kind of cool. But you can see, instead of getting this whole building just blowing away, it's a little bit more interesting now in that we've got some more complex kind of behavior going on. I'm still not kind of getting the nice behavior that I was hoping for with my like sheet metal roof, but that's okay. I mean, you know, we can definitely improve on that. Now, one thing that we could try with that is fracturing it, so we can keep it as RVDs. So that would be kind of, let's go up here. We'll just move this. So here's our mirror. Here's our assemble. So what we could do here is just do a Voronoi fracture, a very simple kind of fracture. Just scatter some points over it. This will give us 1,000 pieces. This scatter by default has 1,000 on it. It's going to turn off create interior faces or surfaces because we only have very thin pieces here without interior surfaces. If I turn on this, you can see there the amount of pieces that we have. And what we can actually do is create connections between these pieces. So here, I'm going to, let's just call these roof underscore pieces. And then we can use this assemble or we can ditch it. The Voronoi fracture actually creates a name attribute for us here, so we can just use that. And if we put a connect adjacent pieces on that, you can see it's actually going to create connections between all those little chunks. And we can kind of create a pseudo cloth sim this way. So you can see if I take that search radius right down, you can see all those Voronoi patterns there. So if we have a look down here, let's just hook this up here like that. Now let's just run it and see what we get. We can create a different one just for the roof, keep it separate so we don't create constraints just for the roof. We might do that. So let's have a look at this one and see how this behaves. And yeah, I think we'll probably have to do a separate one just for the roof. But that, look, you can see it already, and it's actually breaking, which actually I don't want these pieces to break. So I think definitely we'll have to do a separate one. But let's turn off the slop solver and we can see these bend a little bit more. See that? See how they're kind of bending and flexing now, but they're not kind of they're not breaking apart because I turned off that slop solver. They're separating, but that's okay. We have a little trick that we can do after the sim to fix that. So let's turn this slop solver back on, and I'm going to create a separate connect adjacent pieces here. So what am I going to do here? I'm going to not merge in the roof. So I'm going to create my constraints just for the frame, like that. And then I'm going to create a separate network just for the roof over here. Just going to duplicate this. And I'm going to call this one roof soft, like that. Out constraint network. So let's call this out roof constraint network. Yeah, it's a cool kind of way of doing deformation without doing a a cloth sim or something like that. Vellum. This technique is really good for like denting metal and things like that. So I'll just plug that into the fourth input on the .NET, and you can see here our roof isn't coming in because I disconnected it from the merge and this final assemble. So what I'm going to do here is just merge it after. So here's the pipe where it's going off to the connect adjacent pieces for the frame. But if I merge in the roof after that, then that roof is not going to there. It's going to here and getting packed with everything else. And this one has its own little pipe. So there we go. Gets a little bit kind of confusing. You've got to keep track of a lot of things when you start making constraints per object, but it definitely gives you a lot more control. So now what I'm going to do is just duplicate this soft constraint. I'm going to get rid of the SOP solver and just make sure that you get your name correct. So we've got roof underscore soft. Oops. Roof underscore soft. So here, roof underscore soft. We can choose different parameters here as well. We don't have to have the same parameters as what we have up here. Let's just make sure that this is coming in. So data options, fourth context. There we go. We can see there's our constraints just for the roof. And we can choose different kind of settings as well. As we saw, I took that right down. So you can choose different settings. You can even go further probably. And I think turn off the show object link, and then we can just see those little dots there. Guide options, if we up the radius, you can kind of see those little balls, which are all the little constraints. These are very slow to display usually, so I went, because there's a lot of constraints here, so I usually just do that and then turn them off, because it does kind of impact. Oh look, there's something that's really important to turn on, and that's the rest length. So what's happening here, I don't have a rest length checked on here in my connect adjacent pieces. So they're just getting this rest length, which is 1. So they're all getting assigned 1 meter. So yeah, it does look like a spider web. But it's certainly not what we want. So what we need to do is just go on here, check on the rest length, because the rest length will actually be really small, 0, 0, 0, 9. You know, we want them to be as close to 0 as possible, really. A tornado that flew spiders everywhere. I did hear something about that. Spiders raining from the sky or something. Yes. Terrifying. So here we go. Now we can see these panels in the air flying around, but they're kind of floppy, and we can change their parameters to make them more or less floppy. But that's kind of cool. You know, you don't want them to be like cloth, but you do want them to have some sort of level of deformation. The issue with this is that they're not constrained to anything else. So that is the next thing that we need to worry about, and we'll get there. Let's just change some of these parameters. So stiffness, you know, we could take that down so that they kind of behave in a bit more of a floppy fashion. Maybe that's a little too much, but you know, you kind of get the idea. So yeah, let's try 5. And with constraints, one thing that can improve the performance of a constraint or keep these closer together is the substeps. So we try to keep the substeps down as much as we can, but if we increase the constraint iterations, then these things will try harder to resolve together. This one here you can see is, you know, it's not quite getting there, so we could try increasing the bullet substeps as well. Let's put that to 30. It's not really, it doesn't really seem to be helping. So it may just be the stiffness is too low. I'll take those down. It's good to try and keep this as low as possible just for speed. What was that set to? 10. So let's try 8. But as I said, we can kind of fix that after. So now what I want to do is try and constrain these to the poles so that they don't all just fly off at the start. It's kind of cool. It's, you know, sort of what you do see, that roofs tend to get ripped off buildings before everything else. But I want to constrain them a little bit beforehand. So the way that I'm going to do that is I need to take my roof, my roof kind of metal here, and constrain it to, I could constrain it to that beam, but I probably want to constrain it to these. So here's what I can do with that. This gets very tricky, but this is a really cool kind of technique. And basically, if I merge these two things together, these two differently named objects, and put a connect adjacent pieces down, I will get connections between those. You can see if I crank up the scale a little bit, I will get connections. You can see these ones here, probably that connection is a connection from, oh, maybe not. Where are we seeing them? Here. Oh, here. There we go. There's two there. Connection from the metal to the beam. So those are kind of working, but we also get connections between the different pieces of the roof, which I don't want in this. I just want these ones. And I have a kind of convoluted setup for this, but it just occurred to me that maybe I can do this a simpler way by trying to isolate just the primitives, because when you create these primitives, they have a name attribute on them, right? So let's create a marker, which we do have a marker for name here, but I'm going to create one that actually shows the name. So name, like that. There we go. So you can see here that on each end of the primitive, we're just focusing on this primitive here, which is connecting one of the roof pieces to one of the roof beams. You can see at one end it has roof beam 0, which is the name of this particular beam. And at the other end it has roof piece 66. So that's the two ends have different names because they're connecting two different pieces together. So what we might be able to do is say if the primitive has a name of roof beams on it, then don't delete it. So let's just try and see what we can do. So here we've got a name attribute and it's a point attribute. So might be a little bit tricky. I wonder. Let's see what happens if we attribute promote this name attribute from point to primitive. And you can see that you can see now that that name is just in the center, and it copied that name because a primitive, this is only a single primitive, so it can only have one name attribute now. And it's copied roof pieces 66 on it, and it has just done away with the beam name. And the promotion method is average, so you can see it kind of, maybe that's what we can do. We can set it to minimum because it's going to be based on number if we do average or any of these other ones. But because roof beam, this particular beam starts with 0, that is a lower number than roof piece 66, so it promotes that one. And that one gets roof beam 0. Let's see if this works across the board. This could be our saving grace. Just a nice kind of, this won't, the problem with this technique is that it won't always work because it's based on numbers. So we may come across one that doesn't actually get the correct one. But these all seem pretty good because we have much less beams than we do roof pieces. That seems to have worked pretty well. And let's see on the other side as well. It's just a lot of information. Oh, we don't have beams on that side. Let me see. Oh, we do. But maybe we're not getting a connection there. Oh, there we go. Roof beams 22. All right. Well, let's try this. So what we have now is the name attribute promoted to primitives, but we want to keep the original as well. So we've got our name as points here. we're promoting it to primitives here, but we're preserving the original one, crucially. Now, let's, in a wrangle, set to primitives, running over at name equals roof underscore beam, beam, doesn't matter, star. Well, actually, we don't even need to do this in a wrangle. We could just do it in a blast. It's a bit easier. Let's just take that same group name, run it in there, and it's primitive. Delete non-selected. Hey, there we go. Look at that. So, I mean, that is also convoluted, but it's less convoluted than the other method that I usually use. So that actually is pretty good. It's given me all the connections just from the roof piece to the roof beam. So by promoting, yeah, so I think this part kind of troubles me a little bit because it's not very precise, but it works. So, you know, whatever. That's all we can hope for. Now, one thing that you will notice here is that we only have constraints at the tops and bottoms, and the reason is that this works based on connecting points. So these beams don't actually have any points apart from at the top or bottom. If we added, after the edit, because the edit is based on point selection, so we don't want to do anything before the edit, that'll break. If we subdivide this beam after the edit, now subdivide is going to do smoothing as well, but if we override crease weight attribute, just set the crease weight really high, and then we can up our depth, and it's just going to add subdivisions instead of smoothing. So now what we have, still working, which is good, is connections at every one of those little subdivisions. And that means we'll get more of those roof panels connected. So that's cool. Yeah, this is good. I think this seems to be working pretty well. But yeah, just be warned that, you know, there's potential for that method to yield some constraints that maybe aren't quite in the right spot. So at your own risk. But we can take this down. You know, and for me, it's just like, well, if that works, and it works in this particular scenario, that's great. That's what I want. And it takes me much less time to do that than the other method, which involves storing names and calling them back, and it's just a little bit more kind of complex. This is doing the same thing in 2 nodes, which is awesome. So what am I going to do here? This is going to be another constraint network. So I'm going to just copy this, and this is going to be I'm just going to call this roof between, or even like roof nails, why not, something like that. And then this can be roof nails network. So if you think about it, these are like the nails that are holding the metal to the roof, to the beams. And then we can create another constraint. It doesn't have to be a soft constraint, it could be a hard constraint, or it could be a glue, but you know, soft constraints have a little bit of flex in them, so they're kind of a bit more interesting. Let's call this roof nails. Turn that view on and see if we can see them. We've run out of input, so we're going to need to put the path in here. So roof nails network, there it is. There we go, we can see them there. So let's hit play and see what happens with that. And what we should see is these beams actually stay attached now, which is cool. So this way of connecting, you know, certain bits of geometry together is a really good way of getting that complexity into your rigid body sim, where you've got pieces that are kind of meant to be nailed together, staying together. So I didn't really want this behavior where the whole beam pulled off I want these beams to be constrained to everything else. So, you know, that's something else that we need to work on. But you can see that it's kind of, you know, it's doing a pretty good job. So yeah, now let's improve. Probably let's turn off our braking here and see if that kind of helps. So that might keep the beams kind of constrained, maybe. Maybe not. I thought these beams were kind of constrained to this main beam, but you know what? I think all our beams are going to suffer from the same problem, which is that they don't have any subdivisions. So let's just duplicate this subdivide. We'll add it in. Yeah, those ones possibly could benefit, but these ones we can actually just use the subdivisions here because we're not using edit nodes. That's all good. This one as well. Let's just add it up at the top, and then we can actually control the amount of divisions with this if we want. Polygon, not that one, polygon mesh. So we can add more like divisions in that direction and less in that direction and that direction, which just makes for a slightly more efficient model. There we go, and this one. Lots of vertical slices. All right, so what we should see now is that we get much more connections going on between all those things. And what else have we got? Looks like we're not getting a lot of connections up here. I reckon that main beam there. Where's that? There. That one doesn't have any. So let's increase that. That should yield more. Aha, there we go. So now we've got those beams constrained to the main pole as well. So you can definitely see that it's point-based, and the more kind of constraints you have on there, the better. Or sorry, the more points you have, the better. Because if we go back here, set that to polygon again, you can see all of those go away. So that's why those were pulling off. So let's go and have a look. This, you know, this stuff is really time consuming with Bullet, but it's really important for getting a good simulation. So, oh, I just noticed I'm frozen again. Switch to camera 2. So yeah, you know, it is really important, and it's worth spending the time to set this stuff up so that you can kind of get these really kind of nice complex behaviors. And yeah, even though it's kind of a little bit tedious, once you've done it a bunch of times, you kind of know what you need to do. Sometimes you don't need to do like super complex constraints. Sometimes it's, you know, you just want the thing to kind of blow up into a lot of pieces. But when you have like a house and a full construction where you want to see the details and things constrained to each other, then multi-camera, yeah, that's right. I wish I could figure out why my camera keeps freezing. I've watched a few videos about people talking about how to fix it, but I haven't managed to fix it. I think it might just be like a USB bandwidth thing, or I don't know. I'm not sure. This camera, at least I have two. This is the old camera that I had before I got the new one, so it's not quite as good. But yeah, you know, it's now everything's kind of holding together too well. But now we can start to add our little things back in, like our SOP solver, which will break things based on the angle, and then hopefully we'll see a little bit more breaking off. But yeah, this hopefully will add that sort of, that little bit of a pause before the building kind of completely destroys. And you don't want everything to just destroy straight away. Things don't happen like that in reality. You want to build up, like, you know, if it's a shot, you got to build up the feeling of tension, and they're like, oh, it's about to go. Is it going to go completely? No, it's holding together. And then, you know, it destroys. So, you know, building that kind of anticipation within the shot for someone, the viewer, you know, that's what it's all about when you're creating these things. You think about the end goal and how someone's going to watch this, and usually you don't have to think about that stuff too much as an artist when you're working on a shot, because those things will have been kind of set out for you, and you will just follow the kind of brief that you've been given. But if you're creating this stuff for yourself at home or doing your own project, then those are the things that you should think about, is kind of building anticipation and not just having something crumble all at one go, and having detail within a simulation, I think is really important, and it's what can take it, to another level. So we can say it's holding together pretty well, but really, if we have a look back at our play blast, we can see that this house wasn't really collapsing until around 300 last time anyway. So let's just wait till we get more of those tornado velocities coming in, and we can see here now there's a bit more stuff happening. So let's just wait and see. Here we go. It's all sort of starting to peel off now, which is cool. There's still a lot of that happening. The next thing that we might want to do is actually just break up our beams into smaller pieces, because you can see they're staying constrained in these giant kind of logs. In reality, that probably wouldn't happen. The pressures and the forces that are acting on this stuff would probably be enough to snap those beams, especially when you've got nails holding things together. That can just make everything kind of put a lot of stress on the wood, and then you'll see it snap in other parts where the wood might be weaker. And here goes there's a little weatherboard jumping off, but you can see it's kind of dropping back down again, so that makes me think that maybe it's still constrained with the soft constraint there. Let's just view that. Oh no, it's lifting off, but it's just kind of, I guess it's lifting off and then just falling down again. So these constraints of the weatherboards, I think, probably could do with maybe lessening what's going on there, or we can make a completely different constraint network for those so that we can control them a little better. It's kind of cool what's going on with them, but yeah, it's also, they're holding together a little bit too long. I would love to see this roof also not completely lift off. So I think that we should try and improve our constraints between here, and I think probably what's going on there is that they're breaking, maybe based on that angle. Oops, I turned that off. I meant to just turn the display on. It doesn't actually look like there's a constraint happening there, so let's check that out. So here's where we're merging those things together. They're going off to the constraint. So we've got our roof beams, and these ones are the ceiling beams. So we should see a connection between those, but we're not. Maybe the distance is too great, because what you can see here is there's no subdivision here. So there's actually no points until down here. So let's increase the subdivisions on our ceiling beams, or roof beams, I should say. So where is that one? Oh, wrong one. Doesn't matter. These ones. So here, the subdivisions. So that's probably why we didn't end up with so many, because of the subdivide. And the issue with the subdivide is that it's going to kind of not put them all in the right spot. It's just going to do them everywhere. So what could we do? We could just go back before this edit and then redo the edit. It's not too hard to just redo that. We could also do like maybe a loop or something. If we go to the model, I can't remember where it is. I never usually use these things. Edge loop. So we could try an edge loop tool, and you can see I could put an edge loop at the precise part that we need. If I was to template the ceiling beams, you could see I could put an edge loop right there. And then go into my subdivide. Maybe just take that down back to 2. But now, if we have a look at our constraint, we can see we've got this extra constraint being created. So if I turn that on and off, you can see it's creating a lot more constraints there. So it's really important to kind of, yeah, you know, get your model right. There's a lot of prep involved, and it's a hell of a lot easier if you make the model yourself, because you can see I can access all those things, and I modeled it in such a way that makes it easy to access all those things. But if I didn't, and I bought this model off the internet or got a free model of a house, if you don't have access to those things, or it's not an easily kind of subdividable model, or, you know, it makes it really quite difficult. So prep is, you know, a massive part of bullet simulations. Have I seen the Luca trailer? Yeah, water simulation in that was amazing. I'm not sure if I have. Maybe. I don't have the internet open right now. Is that recent or is it old? What is the water simulation? Maybe you can jog my memory. I watch so little movie trailers and movies these days that I'm a bit kind of I'm a bit of a black hole on that stuff. I don't really. People ask me questions about movies all the time, and I never know. Recently, okay, I'll have to check it out. Oh, the Pixar one. Ah, right. Okay, cool. I'll maybe I have seen it. I can't remember. I was just watching something about Salt before. The lighting in that is quite incredible. I'll have to check out the Luca trailer. What is the water simulation, Hardik? I'm sure they did it in Houdini. So it takes a while to kind of see this happening. We could actually start our simulation at 300 just to save us some time. But hopefully we'll see it now kind of doing some stuff. It's all kind of holding together a little more now, maybe. And I think, yeah, what's probably going to be best for the oh, here we go, something happening. What's probably going to be best for the weatherboards is to create a specific set of conditions for the weatherboards. Their water animation, right? Yeah, I'm sure it would be Houdini. I think Pixar uses a lot of Houdini for their effects, as everyone does these days. There was one scene. I'll check it out. That's cool. I'll have a look and see. Water is a lot of fun. I love doing flip simulations, so we can definitely do some more flip stuff. Now our whole roof seems to be going along for the ride. So we're not, those constraints, I guess, are not holding, and that would be because of the angle. So, you know, this stuff you can see it's fiddly. Like you gotta spend a bit of time trying to get it right. And what can be kind of good is to make those constraints really quite hard constraints so that they don't break, but then fracture the geometry itself so that you get things like breaking kind of in the middle. That could be an interesting thing to try. If, like, we took these, let's say these beams, for example. I should label these and make it a lot easier. So let's call these ceiling beams. If we were to take these beams here and fracture these, so Voronoi fracture, just doing simple stuff. I won't do 1,000 fractures. I'll just do 100. Yeah, okay, sure. Yeah, I'll check it out, and next time I'll let you know what I think, or I can give you some insight into how I think it was done. Obviously, yeah, guys at Pixar, they're at the top of their game. They're doing amazing things. Seen such cool things come out of there over the years. So here we go. We've got fractures happening now. So ceiling beams, connect adjacent pieces, and you can see we're actually getting constraints now in between our beam pieces as well. Let's just hide that. So what we'll actually see now is flexing happening within these beams. And we probably do want to check, because we're doing fracturing now, we do want to check our constraint geometry. And it looks okay. I think probably we'll put a little shrink on so that they don't touch. Same with these ones here, because that might just push them out a little bit before they need to break. So it's good to kind of shrink them. You can see how they pop out like that a little bit. So it may be a good idea just to shrink them a little more. I might just revert these to defaults and see what the defaults look like. I think that they're a bit too shrunken. Let's try this. Our scale's pretty small on this thing, so that's why these values are quite low. Let's try that. No, still kind of popping out. It's a bit weird. It's probably maybe just down to the soft constraint kind of wiggling a little bit. One thing that, you know, could help with that is just increasing the glue network that we have here. So we've got this glue kind of holding everything together. If we have a look at that here, so that's that one, kind of holding everything together. So we could just increase. It's a cool image, that glue network. It's like some sort of 80s logo. Is there any future for FX artist jobs in India, or just need to come to Canada? Well, Canada is not your only option. There are lots of options around the world. So yeah, I mean, I think there are opportunities in India. I think probably, I would say the pay is probably not going to be as good. But there are certainly opportunities. You know, there are lots of studios that have studios in India. And yeah, Australia, I mean, you know, Australia is probably a closer, I don't know if it's closer. Yeah, I would have thought it's a closer option for you. Although, you know, Australia just kind of banned all flights from India, and there's quite a lot of debate about that at the moment because of the coronavirus situation, which is, you know, obviously awful, and I feel terrible for anyone that is going through that. But yeah, look, Australia is a good option as well. There are a lot of studios here, and it is very busy. I think at the moment, the one good thing about Australia, if you can get here, is that we don't have you know, a big issue with coronavirus, so it is actually attracting a lot of production to Australia, because there's less of a chance of the production being shut down. So Marvel, for example, are moving their entire studio to Sydney, and they have a plan to make movies there for the next 5 years, and probably longer. You never know. I guess the only issue with Australia, it's a really big place, and there are not as many studios, so it's a little bit different. And if you want to move between studios, you have to travel long distances. But there are a lot of opportunities here, so, you know, I think it's a good option, certainly, but not to say that, you know, don't go to Canada, but don't think that that's your only option. That's all I'm saying. But yeah, you know, London as well is a good option, although that's the real issue, is the size of the spiders. That's right. But if you come down to Melbourne, our spiders are significantly smaller. The hotter it is, the bigger the beast. So let's see what's going on here. I think this is kind of, I don't really like what's going on here. I don't know why it's doing this, but let's just play it and see what happens when we get to 300. Yeah, look, I think, well, you know, obviously I'm biased because I live here, but I think Melbourne is a very cool place to live. It certainly doesn't have the amount of stuff going on that, you know, when I was living in London, that city is crazy, and there's always stuff to do, which is really cool. And there's a lot of film opportunities there. But yeah, you know, Melbourne is a nice city to come to. And we only have two studios. That's the issue. That's kind of, I guess, what you'll find in Australia is that the capital cities just have a handful of studios in each one. That's what I mean by having to move around. Oh, totally. Paris is amazing. I hope one day I can go overseas again. Yeah, Paris is cool. Paris would be a cool city to work in. Not that there's too many studios there. There's Illumination if you wanted to work on animation. But yeah, you know, there's lots of opportunities around the world. You just got to kind of, you choose where you want to go. And you don't have to commit forever. You know, it's the beauty of working in this industry is you can move around if you want to. If you kind of want to go to Canada for a bit, you can. And then if you want to, you know, fly over to Australia and try your luck there, then you can do that. That sort of lifestyle appealed to me, you know, when I was younger, but not so much these days. But those opportunities are there. Obviously, it's different at the moment. Everything's kind of changed, but it'll go back to normal. Yeah, absolutely. Canada has so many opportunities. It's the same kind of deal. You know, the reason Canada has a lot of film opportunities and the reason Australia has a lot of film opportunities is because we offer tax incentives, and that's why the studios come. If that was to ever stop, then the studios would look elsewhere, unfortunately. That is what the industry kind of relies on. But because it brings great opportunities to our countries and because it creates a lot of jobs, the governments usually are keen to keep it because it's a big boost to the economy and a big boost to, you know, to the amount of jobs that people can get and the kind of quality of jobs. So let's see what's going on. So, you know, you can see some really interesting behavior now. Yeah. Looking at the amount of money it brings, I'm not sure it's going to stop now. No, that's right. I don't think it will either. I think you know, sometimes they might reduce them or the tax kind of breaks and stuff. It just depends. But yeah, look, I think, you know, the amount of money that it creates and the profile that it creates as well. I think politicians really like that, you know, being able to say that we have this international film industry. And it brings people from all over the world. I think that's a really good thing. So you're right. It's probably not going to go anywhere. So yeah, you can see these beams now. The fracture is awful. Obviously, it's very simplistic, but you can see how these beams are kind of breaking away now as well. What will be the effects artist salary in Canada or anywhere? Well, it depends on your level of experience, and I can't really say what the rate is in Canada. But if you're talking about Australia, you know, coming in as a junior artist, you're probably looking at about 50 or 60,000 Australian dollars. It's definitely not the highest pay in the world here, but you know, and it just increases as you go up. I think, you know, if you're in America, not that there are loads of VFX studios and jobs in America these days because they're all gone to Canada or elsewhere. In America, those wages are higher, but those jobs are much fewer. Yeah, right. So you're probably getting a little bit more in Canada if you do the conversion. But yeah, you know, you got to start somewhere. So that wage will just increase as you get more experience. And if you're good and in demand, then you can ask for more. So I'm just kind of going through and tweaking these things. I don't like what's going on with the roof exactly. It's kind of getting dragged down. Per month? 50,000 per month? No, 50,000 per year. 50,000 per month? Man, what am I doing here? That's 50,000 to 60,000 Australian dollars per year. For a junior, that is, with 0 experience. So, yeah, I don't love the way this is just kind of crashing down like that. I kind of wish that these parts of the roof would hold on. Yeah, so yeah. I kind of wish these parts of the roof would hold on a little bit longer. So what I might do, I mean, we can go back to our bullet constraint and just increase the angle slightly. See how that affects the simulation. There's in India per month. What do you mean? Sorry, Hardik. You mean you get paid per month? Do you want to know what that is per month? I guess, yeah, just bring up your old calculator. So you'd be looking, if you're looking at $60,000 divided by 12, let's see, you got $5,000 per month, but that's before tax. So there would be tax on that as well. At $60,000, it wouldn't be huge, but you may be taking home $3,500 after tax. And that's per month. So you get tax back in Australia, but yeah, that's probably what you're looking at. So what was I going to do? Oh, I'm going to change this start frame to 300. Or maybe 250. Just so I can save a bit of time and not have to watch 100 frames of not much going on. Yeah, that sounds about right, Audrey. So let's see what this looks like with a slightly increased break threshold on the bullet network. Yeah, it's good to be on top of money, I think, and understand it, and not just kind of I wish that I had known more about money and how important it was to save when I was younger, because I just blew it all. And now I want to buy a house, and I wish that I hadn't spent all my money. It's good to be on top of your money and learn how to be a good saver, because you really need it, especially the way things are going. Well, here anyway, property is so expensive that I think about all the money that I spent over the years and just wish that I had a little bit of it back. But I'll teach my son how to manage it better, so that hopefully he can be in a better position when he's the same age, or even by the time he's 20. So now we're seeing it getting pulled up, which is good. That's kind of, but maybe that's because I started it later, I don't know. I'm still not getting these beams kind of connected here though. So I'm really kind of thinking that it might be better to create a really hard constraint for those. Like, let's go here. Where are we? Here. So there's our ceiling beams. That's what I want to kind of constrain to these guys a little more. So maybe what I'll do here is merge these two together like this. Like that. And then connect adjacent pieces of those. That'll create those constraints. Except, again, I only want these ones and I don't want these ones. I mean, another thing that you can do if you're kind of in a hurry and you don't want to do any kind of crazy setup, you can just select them like this here and just delete and choose delete non-selected. And then I just keep those ones. Now that's a very lazy way to do it, but it's kind of, it's fine. It will still work. And when I'm kind of in a rush, and that's, you know, that's fine, and I don't need to recreate this over and over again, then that's kind of, you know, that's kind of okay to do. It doesn't always have to be perfect and procedural. And quite often with time constraints in productions, sometimes I just need to do something quick, and that will get the job done. So I'm just going to call this beam nails and bring in another. So beam nails network. I might make this one a glue as well. So if we come in here, so you can see I'm ending up with a lot of constraints, but it gives me the flexibility to kind of do whatever I like. So let's call this one beam nails network. And this one could be a glue. And I always forget the name as soon as I've created it. So beam underscore nails. And I can set a really strong strength, or I could set it to -1 even. So -1 on the glue. Let's show the guide. Let's make it pink. So we should be able to see it in here, really small glue. If I set that to -1, those will not break. So these will always be constrained to those beams there. Just that little bit there. Let's see what that does. Basically, we'll probably see that these beams don't really move at all. They'll just, because they're a single piece, and they're constrained at one part by a glue constraint, which a glue constraint can't flex or move. You can see as this piece moves, that whole beam moves with it. And it's no longer constrained up here either. So it may be better to have it as like a pin constraint or a soft constraint that is allowed to flex and move a little bit. I don't know. That's a cool thing though. We can just change what type of constraint relationship we have in there, and it will change. So sometimes glues are better if you want it to be like a more of a hard kind of fixing, like a nail probably would be, then it is kind of good to use glues. Maybe we don't set them to -1, maybe we do set them to have a strength so that they can break. Maybe you make that strength really high. Let's see what happens. What might end up happening, because this is a strong glue, is that this whole beam will fly off with this part of the ceiling beam attached. So that could be an interesting kind of thing that might happen as well. Let's see. You'll be upgrading RAM in your laptop. Cool. How much are you going to get, Hardik? I think that sounds like a good idea, especially if you want to, do a lot of effects work. There we go. So you can see those beams kind of pulling those larger beams with them because of that strong glue. This stuff's a little crazy back here. We've got a lot of stretching going on. But I kind of like, I like what I'm seeing there. Some nice kind of complex behavior. And you can see this roof is really kind of holding on now. So if we go and have a look at our... Let's have a look. Oh, we're inside here. That's a cool camera. Nice. There goes the roof. Let's pull this camera back a little bit. Go kind of here. And I might create another camera. So yeah, you can see this kind of holding together and then kind of flying off. So let's create another camera. Oops. I'm just going to go out here a little bit. So I really like this behavior that's going on here, where they're kind of flopping around and flapping up and down. And then, all of a sudden kind of gets ripped off. So that, I think, is quite cool. Just seeing that sort of flapping at the start is really what I want to get towards. See this here, these kind of stretching things that are going on. So we could, I'm not sure which constraint that is. Let's see, it's this one. This one doesn't have a break set up on it. That's why they're just stretching out really far and holding all together like that. So with this one, we could have some sort of condition where that if they do stretch too much, if we put a SOP solver down on here, plug it in, and have a look at those constraints at that particular moment, we will see probably on the geometry spreadsheet some quite big distances, so 0.17. So in there, if in an attribute wrangle we say on primitives, if at distance is greater than 0.17, let's say, remove prim. 0 at prim num, and 1 for remove points. Like that. And then hopefully, make sure we got that right. We'll have to run that again. Hopefully what we'll see now is that any that stretch too far, they'll just break and separate. Let's see what that looks like. Probably finally what I'll do with this, I'll show you actually what we do with the roof to get it back to being non-fractured, because that's a really important part of this whole setup, is applying the kind of original shape back on, so it's not this all fragmented shape. Hardik says, next live stream, my suggestions: 1 asteroid blast, space station in space. Okay, that sounds complicated, but cool. I like the idea. Keep them coming if you've got more. So let's see. We need to wait a little bit longer. Once we see the roof kind of peel off, then we'll see that stretching behavior happen again. Here we go. And yeah, I think ideally I'd probably refine the look of the weatherboards as well. I think it would be cool to get more weatherboards sort of peeling off. At the moment, I think they're kind of not. Let's see what's going on here. Hopefully it's going to lift off a bit. So yeah, we definitely don't want to see this kind of fragmented look. We want to see the original non-broken part of the roof. Here we go. There we go. You can see them snapping now. And we've actually left with a little bit of roof, which is good. So that's cool. I think, you know, we could certainly improve this a little bit. I think creating a separate constraint just for the weatherboards might be cool, so that they can actually rip off a little bit. These ones, I think, must be the original one here. So you can see them. Because there's so many and there's a lot of constraints holding those together, they're not really getting much angle on them. And the distance is kind of, I guess, not that great. So we do have the name though. So if we have a look back at our original weatherboards, wherever they are, should label them here, not there, here, ceiling beams. Here's our weatherboards. So these have a name, weatherboards, and that will show up in our SOP solver here. So if I was to run an attribute wrangle just on the weatherboards, so group, and I could say at name equals weather underscore boards star, that'll grab them all. And then here I could set a different condition just for the weatherboards. So I could say if angle is greater than 0.01, let's say. So a much smaller angle for that one. Let's see, we can just run it from here and see if it works. See if any of those break off. Or we could check the distance on those as well. So the distance for, let's do, where's the constraint name? Constraint name. Oh, it's a point name. So weatherboards here. It's a little bit tricky to kind of see. So distance, angle is really low on those. So let's go 0, 0, 1. Let's see if that, oh, there we go, removed something. Let's see what that does. Hit play. See if any of those boards fly off. And we could do something other than angle as well for these. So we could do distance. So at distance, greater than, let's just do like a really, really low number. So hopefully those will all kind of break off. They might break off too soon now, but you got to try these things just to see. So it definitely, you know, it's a time-consuming exercise doing this stuff, but it does lead to much kind of better results. So I'm going to hide all of those constraints because the visualizers do slow things down. You can see it going a little bit faster now. The more constraints you add as well, the slower your simulation. So, you know, it does pay to be a little bit efficient with your creation and not just going 10 billion constraints everywhere holding everything together. It does kind of pay to try and keep that down because it will make your simulation very slow. So let's see what happens now with our weatherboards and whether they will peel off. They might just all fall off at once if that is indeed working. I really like the kind of rattling that's going on. I think that's really cool. You know, you could definitely picture the sound that would be making inside there, and you know, all that kind of rattling timber, and I think it could be quite cool. Let's see if when this roof peels off, whether we get any of this stuff. One thing as well that might be stopping these from being completely removed is that I deactivated all of these uprights. So because those are all deactivated, when you constrain something to a deactivated piece, it tends to stay with it a lot longer. So maybe that's something that we could look at potentially. Maybe just deactivating, fragmenting these maybe, and deactivating just the bits that are in the ground. Or yeah, I don't know. Guess we need to play with that. Yeah, you can see they're still kind of constrained. None of them are kind of really breaking off, unfortunately. You can see in here, it's really hard to see on the background. Set this to dark. You can see when some of these things are breaking. So look, there's some down here that are breaking, but not loads. So maybe we'll go even further on this distance and see if that works. Excuse me. And then, yeah, I'll just take whatever this gives me at the end of this, and then we'll just have a quick look at how to apply that kind of original shape back on. I wasn't really intending to spend so long on the RBDs this time because we haven't really done anything else, but maybe I'll try and finish this off during the week, and then I can just talk a little bit more about some lighting and rendering stuff, and maybe some additional elements that we could add before we jump into another project. I like the idea of the asteroid. Is that Hardik? Are you imagining that will be a kind of an asteroid coming down and slamming into a space station and destroying it like that? Have to look for a space station model, or maybe just a spaceship or something. I've got some spaceships that we could potentially use. Let's see what this is going to yield. Come on, weatherboards, do your thing. Looks like there's a bit of stuff going through here. Might need to be fixed. Maybe not. Might be fine. Wow, they're really hanging on there, those weatherboards. So there may be something else constraining them as well. Then maybe I'm not working on the correct kind of piece. I may be wrongly kind of working in one section where I may be should be focusing on another section. Let's just have a look. So I'm pretty sure it's that one. Show object link, turn that off. Yeah, it's these constraints here, so they just don't seem to be really breaking. Perhaps that name kind of stuff that I'm doing is not really working. You know what? I think what I'm doing is, it is deleting constraints, but I think it's deleting the constraint which is between the weatherboards only, and it doesn't seem to be breaking the constraint between here, the weatherboard, and the beam. So that seems to be the problem. Yeah, I don't know. Oh well, anyway, just so we have time to have a look at this stuff, what I'm going to do here is, from this .NET, I'm actually going to use a DOP import. Do it properly. Put the path to the DOP network up here, fetch geometry from .NET, and I'm actually going to not fetch the ground plane. So I'm just going to fetch the RBD packed object, put that in there. Don't want the ground plane in there. And then I need to isolate these roof pieces. So if we select one of those, we can see that the name of that only shows selected. View the name. The name of that is still roof pieces, so we can isolate based on that name. So if we come back to our scene view, blast, at name equals roof underscore pieces star, delete non-selected. They're points at this point, because when we bring stuff out of the .NET, it's packed fragments, so they're points, and the name attribute is a point attribute as well. So there we go, there's our roof pieces. So we can see, off they go. Now, if we find our original roof pieces, which are these ones, what we can do is take our roof pieces here, go back to our first frame, which is 250 at the moment. I'm going to put a time shift down here and freeze this on frame 250. And then I'm going to use a point deform node. And I actually need to unpack this as well. So I'll unpack this here at this point, so it actually shows me the polygons. So I've got frozen polygons. Here I've got my animated ones from the simulation. And into the mesh to deform slot of the point deform, I'm going to plug in my original mesh, which is unfractured. So there's my original mesh. We'll go back to frame 250. Rest point lattice is the frozen start frame of the simulation, which should match. I'll just put a null here. These two should match positions. So they are, because that's the first frame of the simulation, and that's the frozen first frame coming out. Then this input is deform point lattice, which is the deforming simulation. So you can see there's our geometry, our original geometry, and it's now being deformed by our simulated fragments. So you can see there's a bit of stretching going on, so we might need to do something there or decrease our radius, but you can see how they're deforming based on these fragmented pieces. So I think our radius is just way too big. There we go. Take it right down. And there you go. So now you can see our bits of sheet metal deforming, and we're not seeing those fragments anymore. So there's our fragmented section, and there's our newly applied sheet metal. And in here, we can actually make all sorts of changes if we want to. This is very low resolution, so we could do a subdivide. Smooth that right out. Change the crease weight if we want to. We could completely replace it with a different kind of profile as well if we really wanted to. But we could, we could do all sorts of things to this geometry. Even, if we wanted to kind of create some sort of interesting weathered type effect. Let me subdivide this a lot. Maybe instead of subdivide, I could remesh as well. There's no harm in doing that. Target size, take that right down. Let's go 0, 2. Yeah, that looks pretty good. Point VOP, turbulent noise, color. So I'm just going to put a fit down to crush this. This is kind of like doing a contrast on your noise. So you can see there. So I could do some sort of shading with this as well, which could be cool. But what I'm thinking is I'm just going to try and create some little holes in my geometry. So this is like some sort of dilapidated farmhouse roof. In reality, probably there wouldn't be any holes in the metal, or none that are really, really large, but just as a kind of idea. There you go. So you can see, I'll turn that back to light. Based on this noise that I've created, which I can go in and manipulate now, I can kind of add some little holes to this roof. And that's all just going to kind of go along for the ride. You can see a little bit of stretching happening there. That's probably down to just the mesh having too many points there and the point deform just not sampling correctly. We can try and improve that just with the radius and messing with a couple of these settings, but maybe it's just better if I reduce the point count a little bit. So you can see, just adding a few little post kind of holes in there can give us a different kind of look. It's not kind of perfect, but yeah, that can be an interesting technique. Maybe subdivide will work better. And then after deleting, you end up with these really kind of polygonal holes, so a smooth can actually work quite well after that. If I turn off group boundary, unshared edges, group boundary. It's kind of pulling them a little bit far away from the edges. Guess like group boundary kind of works well, but doesn't really smooth out these areas. So maybe you'd need to do something else there. But yeah, anyway, you kind of you get the idea. You can do all sorts of stuff this way and use the point deform or transform pieces node to kind of add additional sort of elements. You can see here. This is the only issue with the point deform is that it's radius based. So because these pieces are quite close together, it's sort of it does create an issue where that radius there is probably greater than this radius. So it's it will select those pieces and pull them along together. So what you might need to do in that instance is create some sort of for each loop, which just loops over each piece individually, which would be difficult at the moment because I guess we don't have an attribute which is for each kind of panel. We just have a name attribute for each kind of chunk. On this one though, we don't have a name attribute, but if we put a connectivity node down, like this, connectivity, that'll give us a class for each connected piece of geometry. Here, after our little blast sort of setup, let's do a for each connected piece, or for each named primitive. Connected piece actually would have worked fine, but let's do named primitive, change that to class, plug that in here like this. This is getting a little bit more complicated, but I think this might solve the issue. And let's choose connectivity primitive. Just reset that. There we go. So there's one panel. If if we do our point deform inside this, that will deform all around. And we can kind of set the radius up a little bit maybe. Now that's bringing in the whole kind of roof to deform this one piece. I'm hoping that that might alleviate some of those problems. No, it doesn't. So what we do need with this is actually this connectivity to flow through our simulation and come out as well with it so that we can isolate. So what we should do is a connectivity up here before our Voronoi fracture that will pass through. So we've got this class, then we're doing a fracture which is generating the name, but the class attribute that we create there will flow all the way through, hopefully. Let's see, here's our dop import, our blast and our unpack. There's our class. So what that will allow us to do is hopefully blast, let's see, blast the same class. So we need to like make, I don't know if we can do, let's try and bring in another block begin and see if that works. So time shift, block begin, block path. Let's copy this. Oop. Fetch feedback, fetch piece or point. For each end, it's kind of not really working. Fetch input. So fetch input is just bringing it in, but I actually want to isolate it based on the class. Default block path, begin, piece block path, begin. I guess I could have another end where I could set a different, so block begin 1. Let's try this. Nope. Nope. I'm totally just kind of making this up at the moment because I can't say I've ever done this before where I've brought it in through a different for each loop. What I probably would do instead is kind of try to isolate the piece based on the class. So if what I could do here, I've got this class attribute, it's primitive. If I put an attribute wrangle here and plug in this guy into the second input and say, let's just make a variable here called int class match, and then put a primitive expression, so prim, so this reads a primitive attribute from the geometry, so 1 for the second input, and let's just see what else we need. We need string attribute name and the prim number, so I'm just going to do 1, and the attribute name is class, and then the primitive number I'm just going to put at prim num, like that. And then I'm going to say if at class does not equal class match, it's getting complicated, remove prim. I need to make this run over primitives as well. Remove prim 0, at prim num 1 for remove points as well. Run over primitives. Hey, look at that. So now I'm getting, wow, it's amazing. It's so good when things work. So now I'm getting the same class. So basically what I said, I brought in the class from this input here. So I'm just grabbing what the class attribute is off of this piece. and I'm storing that in a variable called class match, just so it's stored within the code. I'm storing that value. And then I'm comparing the class that is on this to the class that's on this. And I'm saying if they don't match, remove everything else. So the ones that match stay behind. And then if I do the same thing on this side, there we go. Now, hopefully, there's a little bit of stretching I can see, but hopefully what we'll see is, and it's because it's looping now, it's looping over every piece. So it's definitely going to be a bit slower, but hopefully it will have resolved that kind of problem where we're getting stretching between pieces because we're only deforming one piece by itself and not all the other pieces by the surrounding pieces. So what that probably will allow us to do is to actually point deform, change the radius so that the point deform radius can be a bit higher, and that might result in a smoother kind of simulation or a smoother result. Let's just hit play, let's solve for a little bit because we lost our cache because we added a class attribute in there that wasn't there before. It cleared the cache, so we have to run it again. Let's run it and see if we can fix it. I probably lost everyone while I was doing that, and I apologize. But anyway, it worked. That's the main thing. So let's see. And there you go. I mean, that, you know, Hardik, you were asking about coding and programming. I mean, I am no kind of Vex wizard, but for doing things like that, Vex is incredibly handy. And I could probably do it without Vex, but it might be more difficult, and I might need like a ton of nodes to kind of work that out. But those kind of things are really, I mean, that probably didn't seem straightforward, but relatively straightforward using Vex. And again, it's just practice. I only kind of remember this stuff from practicing it daily. And certainly when you're doing this stuff for work, you're doing this stuff all the time. Like, yeah, you're working on different things all the time. So you're practicing a lot more, and you do become quite proficient with it. Some of those Vex expressions, it took me years to kind of really kind of sink in. So let's have a look. Haha, great success. So you can see now that this piece, and if we compare the result before, what we had was this. So you can see it's fixed that issue because now this piece is only being deformed by that piece. It's not being deformed by any others. So you don't get any of that stretching. You can see there's some weird stuff going on here, but now if we can increase our radius, we might be able to fix some of that stuff, or smooth out some of those results. Maybe not. That might be a really big gap between pieces if we have a look. Yeah, there's a little bit of a gap there. Well, we might be able to improve it just by fiddling with the kind of settings. The other thing that you can do with the for each loop is just run single pass and just focus on a particular piece. You can change that. It's kind of cool to loop through. You can sort of change which piece you're focusing on. Have a look, try and find out which piece it is. It's probably maybe that one, I think it was. I don't know. But that can be handy too if you just want to kind of focus on a particular piece. So there you go. That's a good way of kind of applying that to individual pieces at once. We're not getting the same level of kind of noisy deformation that I was getting before. Maybe that's a good thing. Take that right down, see. You can also take down this maximum points. That can sort of help as well, although yeah, it's not really, let me reset cache pass and see if that changes things. No, it's weird. It kind of isn't really working the same. strange kind of staggering that's going on there. Ah, our class match. Maybe that's why. Looks like our class match is failing here. Look at that. That's not good. So something's... Ah, you know what? We've got two connectivities here. It might be changing the class. Reset. Unpack. Ah, right. So, there. Reset. Yeah, weird. So our class stuff, it seemed to be working, but then for this particular piece, it is not. I wonder if that's because I'm using primnum to grab instead of just a particular primitive. So maybe I'll just try grabbing primitive number 0, the first primitive. Ah, there we go, look. So maybe it couldn't find a primitive number match for that particular piece. So I'll just grab it off the first primitive that comes in. And there we go. That looks better. It looks almost identical, except we don't have that stretching stuff. So there we go. Fixed it. I had a feeling that might have caused issues, but I kind of thought it would be okay. But there we go. So now we've got some deforming. Thanks for sticking with me while I tried to figure that out. So now we can merge that roof, that really kind of high-res roof, back with everything else. So delete non-selected. Now we've got everything else except the roof. Merge those together. So now we've got a high-res roof, and you could do that for anything. Cool, Hardik, thanks. Yeah, I mean, I might do some more on this, or we can start having a look at another project as well. But I might try and just finish this one off with a couple of extra little effects, and talk a little bit about lighting and rendering. But let's finish off the stream just by having a little bit of a preview of this final simulation. So do that, 250, and we'll just see what happens. Well, yeah, we're out of time, so I'm just gonna let this run for however long it takes, and I'll see you guys next week, and we'll try and finish this one off, combine it with the tornado, and look at rendering, and I'll just talk a little bit more about a couple of other things that you could try, and then yeah, we can get stuck into another project. So thanks for joining me. Don't forget to hit like and subscribe if you haven't done already, and I really appreciate you guys showing up every week. So thank you very much for that, and I hope everyone has a great week. So I'll just let this finish off, and then yeah, we can see what it looks like. Thanks, guys.